Section 3.5, Algebra of Functions and Function Composition. So if we have more than one function, we can always add, subtract, multiply, and divide, and we can form brand new function. So this is the notation we're going to use for addition. F plus g. Let's say there are two functions, f of x and g of x. If you see this notation, that means you are adding those two functions. If you see this notation, that means you are subtracting one function from another one. If you see this notation, that means you are multiplying. And if you see this notation, you are dividing. But make sure that while dividing, the divider function should not be 0. Otherwise the function would be undefined. So these are the operation we do between the function. So let's say there are two functions, f of x and gx. This notation means you are just adding them. So the answer for this one is f plus gx is just plug the value of f of x, plug the value of g of x, which is 5x squared minus 2x plus 3x plus 7, and simplify them. 5x squared plus x plus 7. Remember, this notation is just for this operation. After operating them, you are going to get brand new function. You can also name this function as different name like h of x. Okay, here you have given three different functions and you want to find out the difference between two functions and then multiplication at 0. Okay, so let's try to find out here. This is the value of the function. For finding you want to find out the difference and then the value of that function at -8. So what you can do it, you can find out in general, which is just x squared minus 3x plus 1, and g of x is a square root of sorry, it should be minus here, square root of 8 minus x. And now you do the simplification if it's if you can simplify, but it's already simplified. And now instead of x, you just replace that by -8. So this becomes -8 squared. This is 3 times -8 plus 1 minus square root of 8 minus minus 8. So eventually it's 64. This is 24 plus 1, and this is 8 plus 8 is 16. Square root of 16 is 4. So eventually this is 64 plus 24 plus 1 minus 4 is 85. Okay, we can do the same thing here. This is actually multiplication of these two functions and then replacing x by 0. So this is eventually 8 minus 0 times 2 over 0 plus 1, which is square root of 8 is this is 2 times square root of 2. It's a 2 over 1. So eventually 2 times 2 is 4 times square root of 2. Here just a division, so put r of x on the top and t of x on the bottom. X squared plus 3 over x plus 4. If you can simplify this, then simplify, but there is nothing we can simplify here. Now we try to take two different functions and we try to define or create a new function, and then process of creating that new function is called composition. So let's think about two different functions as a machine. The function 1 is g of x. G is a machine. Function f is another machine. So for any functions, there is an input, there is output, input and output. Remember, these inputs and output might be different depending on what function you have. We name them as a domain and range. Domain and range. Our goal is to create the brand new function by using these two functions, by connecting them whenever it's possible. Not always possible. Whenever it's possible, we try to connect them like this. So whatever output we get from g of x, this first machine, we are just sending that output to the second machine as input. Whenever that thing is possible, we can create a brand new function, and that's called composition of functions. And this is the notation we use for the composition, and we read it as f composite g. This symbol like this whole or 0 is not 0 or whole, it's just a notation for composition. We are creating a new function by using g as a first function and f as a second function, and that the value of this function can be calculated by using this, the value of f at g of x. This is called composition of function. And then this order matters. If this f comes here and g comes here, instead of writing f composite g, you would write g composite f. Okay, so what is the definition? The composition of f and g, denoted by f composite g, is defined by the value of the function at g of x. And now if you are interested to find the domain of composition is the set of real number x in the domain of g, such that g of x is in the domain of f. So the meaning is, you have to make sure that whatever you are getting from as output from the first function, that should be can be taken as the input function for the second function. How do you find it? For finding, just use this one. F composite g means you are trying to find out the function f at g of x. So it's like this. You have given f of x and you want to find out the value of f at some box. What do? You just replace wherever you see x by that box on the right side. So it would be 5 times box square minus 1. Okay. In our case here, instead of box, we have given g of x. So what do? We just copy this function f of x, and wherever we see x, we just replace that by g of x. Okay. So now, finally, we plug the value of g of x, which is a square root of 5x plus 5 whole square minus 1. So square of the square root means there is they will be cancelled out, and eventually you are going to get this. And now if you distribute 5, it will be 25x plus 25 minus 1, which is 25x plus 24. So that's the composition of two different functions, and that is giving you the brand new function. If we change the order, if we try to find out the g composite f, we are finding the function g at f of x. By doing the same thing, look at the function g of x, and wherever you see x on the right side, just replace that x by f of x. Eventually, plug the value of f of x, which is 5x squared minus 1 plus 5. And if you try to simplify this, it's a 25x squared minus 5 plus 5. This is cancelled out, and the square root of 25x is actually 5x. So f composite of g is 25x plus 24. G composite of f is 5x. So they are, two different functions. Sometimes they might give you the same answer, and that will create the very unique situation, and that's what we're going to define or discuss in next section. But for now, just the composition.